Good morning to one and all. Welcome to the semester 2 of your first year. Hope are you the safe. From the first of the Feb, there will be the physical classes. Before that, you have to take the vaccine. There is a vaccination drive, especially for the student ranging from the 15 year to the 18 year. Vaccine is there. You have to take that vaccine. Okay, and physical classes will be from the first Feb. Today we have to discuss about the syllabus of Unit 1 of Chemistry 1 and Chemistry 2. Then we will proceed further one by one. Just I am sharing my screen. Tell me the screen is visible.
Yes,
Screen is
sir.
visible.
Sir. Yes, sir.
Okay. Okay. Here we have to talk about the syllabus for this semester 2 for the paper 1 and paper 2 unit 1. In the unit 1 paper 1, there is a two lessons are there. One is the gaseous state. In the gaseous state, we have to talk about the ideal gas law, kinetic theory of the gases, Maxwell-Boltzmann distribution of the velocities, their qualitative discussion. Then ideal gases, real gases, compressibility factor, Boyle's temperature, and the numerical based on these things. Then deviation from the ideal gas laws, reason for deviation from ideal gas law, van der Waals equation of the state. Then Joule-Thomson effect, we have to see quality discussion and its experimentation, inversion temperature, and the numerical based on this particular we have to solve. The second lesson from this unit is the chemical equilibria and thermodynamic parameters. In that, we have to talk about what is a reversible and irreversible reaction, then what is the applicability of the law of mass action, then dynamic equilibria, equilibrium constant, relationship between the Kc and the Kp. Then next, Le Chatelier's principle, then factors affecting the chemical equilibrium that we have to discuss. Then statement of the second law of thermodynamics, concept energy, spontaneity, and physical significance of the free energy. Then next, we have to talk about thermodynamic derivations of the equilibrium constants and numerical based on that. In the paper 2, unit 1, we have to see there are the three small lessons are there. One is of the ionic equilibria. In the ionic equilibria, we have to talk about the electrolyte, dead type, strong, moderate, weak, the degree of ionization, factors affecting the degree of ionization constant, ionic product of the water, ionization of the weak acid and the bases that we have to see. Ionization is nothing but the split up into the its own ion. pH scale, common ion effect, dissociation constant of the mono, di, and triprotic acid. Then exact treatment for the monoprotic acid that we have to see. In detail, we will see during this particular R syllabus. Buffer, introduction, types of the buffer, derivation of the Henderson equation for the acidic and basic buffer, buffer action and buffer capacity. Numericals are also there. Second lesson is nothing but a molecular spectroscopy. We have to talk about the electromagnetic radiation, electromagnetic spectrum, Planck's equation, then interaction of the electromagnetic radiation with the matter. In that, we have to talk about especially absorption, emission, scattering, fluorescence, electronic vibration, rotation, transitions. These all things we have to see. And there is one law, that Beer-Lambert's law is there to correlate this particular interactions. And so again, the small lesson is a solid state chemistry. We have to talk about the types of the solid. This all part you have studied in the 12th. That all syllabus was there in the 12th. Crystal lattice, lattice points, unit cell, space lattice, lattice plane. Laws of the crystallography, law of constancy of interfacial angle, law of symmetry, and law of rational indices. This we have to see. This is the your syllabus for this particular semester 2 for the paper 1 and the paper 2. We will start with the paper 1. Okay, that already we have discussed gaseous state. That what we have to see. This is your whole syllabus for this particular paper 1, unit 1 for the semester 2. Now, very much important thing is that what is the ideal gas law? Okay, before studying the ideal gas law, we have to talk about these three different laws: Boyle's laws, Charles law, and Avogadro law. These three laws comprises the ideal gas law. The question sometime may be the state Boyle's law, Charles law, and Avogadro law. Boyle's law is nothing but at a constant temperature, the volume of the given amount of gas varies inversely with its pressure. What is the statement of Boyle's law? Boyle's law says that at constant temperature, the volume of the given amount of the gas varies inversely. Means V is inversely proportional to 1 upon P at N and constant. Okay. Therefore, that proportionality constant is nothing but a K. V is equal to K upon P. That simply PV is equal to K. This is the equation number 1. Avogadro's laws, at constant temperature and pressure, the volume of the given amount of gas varies directly with its number of moles. What is there? At constant temperature and pressure, the volume of the given amount of gas varies directly, means V is directly proportional to N at constant pressure and temperature. Then third, Charles law. At constant temperature, the volume of given amount of gas increases or decreases 1 upon 273 times of its volume at 0 degree centigrade with every degree rise or fall in temperature. It is a Charles law given at constant pressure, volume is directly proportional to temperature. Means as the volume changes, temperature changes. As the temperature changes, volume decreases or increases, like that. At N and P is constant. Therefore, V is equal to KT, where K is equal to V upon T. At constant volume, the pressure of the given amount of gas varies directly with its absolute temperature. Therefore, P is directly proportional to T, and N and V is equal to constant. P is equal to K into T, K is equal to P by T. This is the equation number 3. We have to combine this all this equation 1, 2, 3. On combining equation 2, 3, we will get PV by T. This PV, this equation that you have to see. 2 and second and third equation, when you will combine, at that time you will get PV upon T is equal to K at constant N. After combining all four measurable properties P, V, T and N, you will get PV is equal to nRT. We will get the ideal gas equation. V is directly proportional to NT upon P, that is the PV is equal to PV directly proportional to NT. Okay, and this proportionality constant is nothing but the R. That's why PV is equal to nRT. This is the ideal gas law. Are you getting that? Please unmute and say something. Hello. Hello.
Yes, sir.
Yeah.
Yes, sir.
Have you got this concept? How the ideal gas laws come? Ideal gas law derived from these three basic laws: Boyle's law, Avogadro law, and the Charles law. After combination of all these three laws, means the Boyle's law, Avogadro's law, Charles law, you will get V is directly proportional to NT by P. That is PV is directly proportional to NT, and that proportionality constant is nothing but the R, and R is known as the gas constant. This equation PV is equal to nRT is known as the ideal gas law equation or ideal gas law. Where R is the universal gas constant. Okay. This is your about the three questions are there: state Boyle's law, Charles law, and Avogadro's law, and a whole about the ideal gas law. Ha, I have not, I think, you shared the notes. Have you received the notes for the chemistry? Hello. Have you received the notes for this chemistry?
No, sir.
No, sir.
No, sir.
Okay. Today you will get, huh? Today you will sure get. Just I will share from my mobile. I forgot yesterday. I was remember, but don't know how I forgot. Okay. Have you got this particular ideal gas law?
Yes, sir.
Yes, sir. Yes, sir.
Okay. 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 हेलो, have you seen that particular thing? किसने कितने जल्दी आंसर दिया है? Solia Haldi given the answer within that particular 4 seconds, Adina given in the 6.9 seconds, and Fatima given it is in the 7 seconds. Okay, that was a different idea for that. Okay, you enjoyed, I think so.